All right, so with problem number 60, I didn't go over amplitude and stuff like that yet. We haven't talked about amplitude and period yet. We'll do that after the midterm for the final. But it doesn't mean you can't do it. So the key here is I can solve by just dividing, right? By -4 divided by -4. And so I get cosine of theta is equal to 1/2 negative. That makes sense? Okay. Make sure I'm recording. Okay. So then I take the inverse cosine, and that's going to give me an angle. And if I plug that in, it should give me 30. Okay, but I want to show you why it gives you 30. I don't have my phone on me, so I actually have to use one of your calculators. And I don't see one very close to me. Okay, so let's just double check. So second cosine, and so -0.5 equals, and it comes up with 120. Okay. So it's coming up with 120 degrees. Now that's because it's only giving me within the first pi. Now did it say, is it going to 2 pi or, yeah, so it's going to 2 pi. Alright, so it says 120 degrees. So it's equal to 120. And now I'm going to show you why I came up with 30. Okay? So 30 is actually, gee, Christmas. Alright, so 30 is your reference angle. Right? So it's, explain that reference angle. So when we talk about 30, 60, 90 triangles, we have this special 1, square root 3, 2, right? And when we talk about or cosine, we're talking about the adjacent over hypotenuse, right? And we also know that the hypotenuse cannot be negative. So the only thing that can be negative here would be would have to be the adjacent side, right? And we know that if we go right, that we're going to be positive, right? If we go right, it's going to be positive. So these two are not going to fit. What the two angles that we're really looking at is this angle and this angle. Okay? And it creates two special triangles. Right? It creates this triangle right? Whereas when we think about that, if this is 30 degrees, because that's 30 degrees, right? And the opposite side would be a 1. This would be a 2. And this length of the adjacent side is going to be the square root 3. Is that right? Okay, and so I think what we really want is to look at the, we're thinking about not the 30 degree angle here, but the, I was thinking 30 for some reason. 30 would be 1. Right? 1, yeah. That's opposite. So I'm thinking the other one. So what we really want here is the 60. Because we want the adjacent to be 1. Right? We want the opposite side to be the square root of 3. And of course the length of the hypotenuse is going to be 2. In that case, when we think about it, we're still going to think about it in the same aspect, except it's going to be this one and this one. I'm sure it's too steep. This one. Okay? So we've got, this is going to be 1. Okay? And the hypotenuse right here is going to be 2. Okay? Except this length is going to be actually -1, right? Of 60 degrees. So we're talking about a 60-degree triangle. Okay, where this is 60. Where we have a 1. And in this case it's going this direction, so it's -1. The hypotenuse is 2. Okay? So, but this is a reference angle, right? It's a reference of 60. So therefore we have to think about, well, what is this angle? From here to here. So if we think about that, we're going from here to here, that would be a 60 from 180, right? Because this is pi or 180, right? So 60 from 180 leaves us with 120. Okay? So that's why it's coming up with 120. But it wants to know 2 different ones. And later, we're going to show you how to graph these. And this is the graph of cosine. Okay? And what we can see is that it comes up when it's -1. It's actually going to come up twice. There's 2 answers before it hits its period. And it always has a period. Oh, it doesn't always have a period of 2 pi. But a basic cosine has a period of 2 pi. And it finishes its rotation at 2 pi. Okay? And so from 0 to pi, or from 0 to 180, the first spot's going to be at 120 degrees. Okay? That's when the cosine of theta is going to equal -1/2. The other spot, okay, this spot right here is going to be at this point, when we have -1/2 again. And that's going to be 60 degrees more. 60 degrees more than 180. So we have to look at 180, add 60, 240. Okay. And so we know that it's going to happen 2 times. It's going to happen, so theta is going to equal both 120 and 240. Okay? And if it were to ask us within 4 pi, within 5 pi, within 3 pi, we could still figure that out. If it were 3 pi, we would go that far, right? If it were 4 pi, we'd do another one of these, and so forth. So with 3 pi, there'd be this one, and that one. And again, it would be 60 degrees before you get to the 180. So you go around once, 360, and then 60 before you get to this next 180. So whatever, 360 plus 180, that'd be 460. That'd be 540 minus the 60, which would push you back to 480. So this one would be at 480. And that's how you would figure those out. Okay? And if they wanted them in radians, it's just as easy. Right? Because if we know that these are pi's, right? This is 60. So there's going to be, 60 is always done in 6s, right? Pi over 6. Right? So 6 pi over 6. So this one would be 1, 2, 3, 4 pi's, right? Over 6. Or 2 pi over 3. And then this one would be 6 and then 7, 8. So 8 pi over 6, which is 4 pi over 3. So we could actually give them in radians also. 2 pi over 3 and 4 pi over 3. Okay? And if we think about that, why is it coming up as 3? And then think how many angles there are in 180. How many 60-degree angles are there? There's 3. Right? So there's going to be 1, 2 here, and then 3, 4 to get here. So 2 pieces of the pie to get to that one. 2 60-degree angles, right? To get to 120. 60 and 60 is 120, right? And then there's going to be 4 pieces. So 4 times 60 is 240, right? So hopefully we'll start seeing that this is it's just pieces of pies. Okay? Questions? Does it make sense?
Not really.
No? Then there should be questions. What don't you understand? Everything. Do you understand that this part, where we have the unit circle, right? And we're creating an angle. And we're saying somewhere in here is going to be an angle. When I take cosine of theta, it's going to equal -1/2. And then these points are those angles. Right? Okay. Now, we know, because it's an adjacent side, we know that this, because this is the adjacent side, this side is positive. Going that direction is positive. That's why it's not going to be this side. This side is null and void. So we're not worried about this side. We're just worried about this side. And then we want to take a look at the hypotenuse, right? Versus the length. And now it comes down to that basic triangle of that 60-degree triangle, that the opposite side is the square root of 3. This length is 1, and this length is 2, right? And when I'm saying cosine, I'm saying the adjacent, right? The adjacent over the hypotenuse, right? And because I'm going this direction to get to it, this is actually -1. So now when I'm talking about cosine of 120 degrees, right? 120 degrees, meaning I'm coming all the way around to here, 120 degrees. I'm talking about the actual reference angle of this 60 degrees. But the reference is in reference to the -1 in the x direction and the distance of 2. So we have -1 in the x directions and the distance of 2. And therefore, that's going to equal -1/2, which is what they're asking us to solve. Does that make more sense? Okay? And then we do the same thing, right, as we're going to find the other one. So by looking at this curve, I can see that I have 2 answers, just like with parabola. You know how you have 2 answers, right? Well, with cosine and sine, they go forever. They look like this, right? And so you always have multiple answers. So with parabolas, you only get 2 answers, but with cosine and sine, you get infinite. And that's why you'll always get asked questions between periods. And in this case, they're saying between, I think they said between 0 and 360, right? But sometimes they're going to say between 180 and 400, or they might keep it simple, 180 and 570, okay, or 900. And then you have to go through and figure out how many times it's going to hit that thing, and then at which angle. And that's why we were trying to figure out how to draw an angle, right? You're like, why should I draw an angle? That's what a lot of you were thinking. Why am I drawing this angle that goes around in a circle, right? And the reason is so that when we ask you later to give us the angles that happen between pi and 5 pi, you can draw your equation, find your reference angle, and from your reference angle you can find all the other angles. Okay? And so the only other one that's going to have a -1 as your distance is going to be this angle right here, which is going to be 60 more than 180. So you just add 60 to 180 to figure out how far that is. And 60 plus 180 is 240, and that's how we're coming up with the 240. Little better. Jordan's going, I almost have it. Kind of, but then I lost it. Right? Okay. Yeah. Hopefully the video will help.